Let us just discuss a little bit unit cell. So what is unit cell? Okay, so unit cell, it is the smallest three-dimensional repeating units. Okay, it is the smallest, okay, it is the smallest three-dimensional repeating portion of, it is the smallest three-dimensional repeating portions, okay, repeating portions of space lattice. Okay, so what does it mean? It means that you can see that in a puzzle, one cube is there. In that puzzle cube, you will see that we used to rotate it this way, right or not? In that puzzle cubes, you will see that small boxes will be there, and it will together make a big box, right? These small boxes, that is, you can say the small cubes, it is combined together, and then it is making a lattice, right or not? So this one whole thing, the puzzle one cube as a whole, it is called as what? Lattice. And the small cubes which are combined, so different color cubes which is combining together, so that one will be called as what? Unit cell. So you can see that this unit cell is repeated 1 2 3 4 5 6, it is repeated one after another in some order, and that repetitions it together, it gives us what? A lattice. So this one, it will be called as what? This small part will be called as unit cell. It's not that only this one will be called as unit cell, any one part of it, it will be called as what? Unit cell. Okay. Now dear students, we are going to study about types of unit cells. Okay, so types of unit cell. So basically there are different types of unit cells are there. The first type of unit cell is primitive. We call it as primitive unit cell. Primitive. Okay, primitive unit cell, or we call it as unit cell, or another name is simple unit cell. So in this cell, what will be the arrangement of the constituent particle? How the constituent particles will be arranged? Let us see. Let's assume that this is one cube. Okay, this is one lattice. In this lattice, it will be made up of what? Constituent particles. So let's assume that the constituent particles are like this. These are the constituent particles. How many constituent corners are there? 8 corners. So the constituent particles will be present at the 8 corners. So in primitive cells, you will see all the constituent particles are present at the 8 corners. Okay, so this one, it is called as what? A primitive unit cell or a simple unit cell. Now if I want to calculate what is the number of atoms which is there in one unit cell, so primitive unit cell, then we write here number of atoms. Very important part, generally it used to come for choose the correct in your board examinations. Okay, so listen it very carefully and try to understand. So number of unit cell or number of atoms in primitive simple unit cell. Okay, or you can write primitive unit cell, simple unit cell. So number of atoms in simple unit cell, how much it will be? See, it looks like whole constituent particle is inside. It's not like that. Okay, this spherical surface, it is like this, and it is divided into 8 parts. Okay, out of that 8 part, only one part is inside the cube. Here also only one part is inside the cube, one part is inside the cube, one part is inside the cube, and remaining portions of the sphere is outside the cube. That means remaining 7 part does not contribute anything to this cube. Only which part is contributing? Only one part of the sphere will contribute. And how many corners are there? 1 2 3 4 5 6 7 8. So there are total 8 corners. And what is the contribution of each corner? The contribution of each corner is 1/8. Because out of the 8 part, only one part is included here. So it will be 1/8. Cancel. So number of atoms in simple unit cell is 1. This point you have to remember it, very important. Okay, so hope you have understood what is primitive or you can say simple unit cell. Next type of unit cell we are going to discuss is face centered unit cell. Okay, the second type we are going to discuss is face centered unit cell. Okay, so what is face centered unit cell? Let us try to understand. Number 2, face centered unit cell. Okay, face centered unit cell. In the face centered unit cell, its short form we write FCC. In the face centered unit cell, you will see that in a cube how many faces are there. This one, 8 constituent particles at all the 8 corners. It is compulsory in all the types of unit cell. Okay, it is not that it is going to change. It will be there in all the types of unit cell. But beside this also in FCC there will be some extra thing. Extra thing will be what? How many faces are there? You see, this is top face, this is one side, then this is one side 3, one side 4, one side 5, and downside it will be 6, right or not? So that means 6 faces are there. If you are not understanding it, then you can understand with this one very easily. Suppose this is a cube. It's not a cube, but let's assume that it is a cube. So how many faces is there? 1, 2, 3, 4, 5, and downside it is 6. So 6 faces are there. So in the face centered unit cell, all the corners, here also one constituent particle, here also, 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 we have drawn these circles. It will be present in all. Beside that constituent particle, one constituent particle will be present here at this face, and that one also half up outside and half inside. Here also one constituent particle will be present, half inside, half outside. Here also one constituent particle will be present, half inside, outside. Here also one constituent particle will be present, which one will be half inside the cube and half it will be out. Here also one will be there, and at the bottom also one will be there. So total faces are 6. So number of constituent particles, here will be 1, here it will be 1, here it will be there 1, here it will be 1, here it will be 1. Okay, since it is a 3-dimensional diagram, so I cannot represent all the things here, but I think you have understood the example. So 6 constituent particles beside this corner one, there will be 6 constituent particles will be present at the surface. So we'll write here number of atoms present in what type? Present in FCC structure. Okay, number of atoms present in FCC structure will be what? This 8, so it is already there, plus 6, and what is the contribution of those 6? Half. So we'll write here 1 by 8 into 8, that is present in all the corners, plus how many constituent particles beside this are present? 6. And what is the contributions to the cube? They are present half inside and half outside, so it will be half. So it will be 2 into 3, 6, 8, 1. So 1 plus 3. So total number of constituent particles there, students, or total number of atoms in FCC will be how much? 4. It generally comes in your this NBSE exams for 1 mark. Choose the correct. This is very important. Okay, very important, dear students. You should remember, in the numerical problem also it will be helpful to us. So that's why it becomes very important for us to remember it. Okay. Now pause the video and you can take it down. Next, the third type of unit cell we are going to discuss is BCC. Okay. Got it? So BCC we are going to discuss. Okay. Body centered cell, unit cell. So third one is body centered unit cell. So body centered unit cells, you will see the number of atoms in what is this? BCC. Okay, so it will be number of atoms in BCC is equals to how it will be the structure. Sorry, I have rubbed it. So again we have to draw. Structure is like this. It will be same structure only, but a little bit differences will be there in the body center. First of all, you should know what is body centered. Okay. Okay. So at all the 8 corners, that is compulsory, it will be there 8 constituent particles. Plus, beside this constituent particle in the body centered, at the center of this cube, in the center of this cube, a space will be there. So that space one whole constituent particles will be present. Okay or not? This is at the center inside. It is not touching any edge. Since it is a three-dimensional space, so you have to imagine a little bit. Suppose this is the cube, and inside this cube at the center it is present. So you can see the whole entire sphere is present inside. That means it is one atom is present inside beside the constituent particles which are present at the corner. So we'll find out number of constituent particles. So as usual, 8 corners are there, so it will be 8 plus how many? 1 is present at the center or not? So plus 1. So it will be equals to how much? 1 plus 1 equals to 2. So number of atom in BCC is equals to how much? 2. So if it is asked in the questions, they will be asking the numerical, the BCC structure. So you should know that the number of atoms in BCC, that is the value of Z, will be Z will be how much? 2 in BCC structure. Okay. So dear students, I hope this points is clear. Okay, this is very, very important. Now we shall move on to the next topic. Okay, that is relations between the diagonals, relations between radius, edge length, diameter, and the 4 different cells. Okay, or unit cells. So the next topic we are going to discuss here is relationship between R, D and A. Okay, relationship between R, D and A, where we can write where R equals to radius, D equals to diameter, and A equals to edge length. Okay, A equals to edge length. Now fine. So first we will discuss for what? For a unit cells. Okay, for simple unit cell. The first type of unit cell is what? Simple cubic. Simple cubic. Or we call it as primitive unit cells or simple cubic unit cells. So for simple cubic we are going to discuss. So dear student, as I have told you that in the simple unit cells there is the presence of unit cells are there at all the corners. Okay, only they are present at where the unit cells or the constituent particles are present only at the corner. Right, so here it is present one. Actually it is like this. Okay, it will be present in this way, and this one it will be like this, and this A also it will be this way. Okay, actually my diagram is not that proper, you have to imagine it. The constituent particles which are present at these corners, okay, they will touch each other. Okay, they will be touching. This is the upper face only. Here also it will be same thing. So they are touching each other. That means the radius of this sphere and the radius of this sphere is R. Okay, and this is what? One side of the cube or not. This is one edge of the cube or not. And we know very well that cube, all the edges are equal. So this one, if you add it up, then this one becomes what? A or not? And these two radius, if you add it up, then it will become what? D, diameter. So we'll derive the relations. Okay, try to understand. Okay, these spheres which are present at the corner, they are touching each other. Okay, got it? So we'll write here. Here R is equals to D by 2, and D is equals to A, because this R plus R is what? A or not? So edge length. So we'll write here A by 2. So for the simple cubic, this is the relations between R, D and A. This formula is very, very important. It used to come in your NEET exam. This year also there was a questions on this. So dear students, I'm telling you, try to understand it properly. Okay, the relations for simple cubic is what? R equals to D by 2 equals to A by 2. Number 2 we are going to do for FCC. Okay, so FCC, what will be the relations? Let us see. See, here edge length is like this, and in FCC I told you each faces there will be one extra circle also will be there, right? There will be one extra circle as well at the center, right? So if we want to draw it, then properly let me draw and tell you. Diagram is actually it is a three-dimensional diagram, so you have to imagine a little bit, okay? And my diagram is a little bit dangerous, so all of you try to adjust, okay? So here is the unit cell, here is the constituent particles, here is one constituent particle, here is one constituent. In all the faces there will be one, okay? But we are not going to consider all the faces, we are going to consider only one face. Suppose here this is the face center, so here also it is there. Now it looks that they are far away from each other, but actually this one and this one they are touching each other, this one and this one they are all touching each other, okay? So it will be like this. Got it? So they are touching each other, and this triangle का name let us write ABC. So let us put the name ABC. Okay. So we know the edge length. This is the edge, so it will be A. Okay. Got it? And this is what the diagonal. Okay. Got it? So so we are going to do number 2, that is for FCC. So we have drawn here FCC, all the edges there will be a constituent particles, 8 corners there will be 8 constituent particles, and plus at each faces there will be one constituent particle. So we are talking about the top face. So here is one constituent particle, here is one, and here is one. We have drawn a straight line, and we have made a triangle ABC. Now in triangle ABC, AC becomes AC becomes a hypotenuse. This is base and this is perpendicular. So we have taken in right angle triangle ABC, AC equal to AB square plus BC square. AC square, AB का value will be how much? A, edge length of the cube. BC का value will be what? A. So A square equals to, add up to A square. So AC will be equals to, the square will be shifted that side, then it will become what? Root over 2A square is equals to this square A square, it will come out of the root A root 2. It will be equation number 1. Now what we are doing after getting this, again we are writing in, this is in terms of edge length. Now we are writing AC in terms of radius. So AC will be equals to this radius, and here complete sphere is there, so 2 radius plus here 1 radius, so total becomes 4 radius, right? 1 2 3 4 radius. So 4 radius. So 4 radius means I can write it like this or not? 2 into 2r. I have written like this. So 2, and this 2r is equals to what? We know d equals to r by 2. We know what d equals to, or you just say we know r equals to d by 2. So d will be equals to what? 2r or not? So in place of this 2r, I can write what? D. So we have written here 2r. In place of 2r, we have written d. So it becomes 2 into d. This 2, if I take it this side, then d will be equals to what? AC divided by 2. What is the value of AC? We have a root 2. So we have put a root 2 divided by 2. So this 2, I can write it, 2 can be written as what? Root 2 into root 2. So I have written root 2 into root 2, root cancel. So what we got? D ka value finally. What is the relations between A and D? Between A and D, the relation is D equals to A by root 2. So D equals to A by root 2. I got the relations between D and A. And what is the relations I got between R and A? So R is equals to D by 2. Half of diameter. So diameter, what we have? A root 2 and by 2. So this root 2 will come down, then A to root 2. So for FCC structure, remember dear students, for FCC structure, the relations between R and edge length is equals to A by 2 root 2. This point you have to remember it properly because it will be required in the numericals. It comes in your NEET examinations, JEE examinations from here. Question used to come. So it is very, very important, dear students. You should remember it. Okay. Now moving on to the third one. Okay, so the third one we are going to do, that is BCC structure. Okay, body centered ka. You should take it down these things, okay, because it is very important for your numericals problem, for your JEE and NEET examinations, so you should remember. Now we are going to discuss the third type of unit cell, that is BCC, body centered. Okay, so in the body centered, okay, I won't be stretching much. In the body centered, directly we will be writing that we got in the previous diagram AC equals to A root 2, right? We got it in the FCC diagram. We have got AC equals to how much? A root 2. Now here, when we will be using it, D equals to root 3A by 4. This is the formula for D equals to root 3A by, actually it is root 3A by 2. Okay, the relations between D and A is what? D equals to root 3A by 2. So what will be R? R will be equals to D by 2. So D is this much, so you write it root 3A by 2 by 2. So this 2 will come down, then it will be what? Root 3 by 4A. So this is the relations between the radius of a BCC structure, radius of a BCC spheres, and the edge of a cube, that is root 3 by 4, and the relations between diameter and edge of a cube is what? D equals to root 3A by 2. Main is the formula. You should remember this formula. Derivations and all, it's not that important, but formula is important because it will be coming in the numericals problem, or directly this related questions also used to come in your exams, entrance examinations. Okay, so hope you have taken down. If you have taken down, then you can pause the video and you can take it down. Okay, let us do one questions, numerical problems here based on these formulas. Okay, based on these formulas, the question is tungsten crystallizes in a body centered. Tungsten crystallizes, crystallizes, crystallizes into a BCC, body centered. Okay, tungsten crystallizes into body centered cubic unit cell, body centered cubic unit cells if the edge of the unit cell is, if the edge of the unit cell is, if the edge of the unit cell is 316.5 picometer, what is the radius of the tungsten atom? What is the radius of tungsten atoms? This is the questions which is asked in your exam, and this is also asked in 2017. Okay, CBSE 2017 2018, it was asked in a sample papers. Okay, so it is important questions. Okay, and like this question is very important and easy also. Okay, dear students, see, if you really want to learn something from these videos, my videos and all from my channel, then you have to watch the video completely. You are not watching the videos completely. If you are not watching complete videos, you will not understand what is being discussed. Just coming and going, it will not work. Little bit patience you need to have in order to watch the videos. Okay. So tungsten crystallizes into BCC unit cells if the edge of the unit cell is 316. That means what they have given. What are the things they have given here? The things given here in these questions are given age is given. So A equals to 316.5 picometer, it is given. Okay, got it? So this is given. Next they have given what? BCC. So in the BCC we know BCC structures, what is the relation of edge length and the radius. What they are telling? Find the radius, and here it is given what? Edge. So what is the relations of radius and edge in the BCC? Right now we know what we know, that R is equals to root 3a by 4. This is the relations between edge length, okay, and radius for BCC. So R we don't know, so root 3 by 4, and here A is given 316.5. So what you have to do, 1.73 into 316.5 divided by 4. You have to do it in this way, okay? So when you will be multiplying and dividing, you will be getting here how much? 137.04 picometer. Okay, so this will be the answer. So see, question is 2 line, answer also 2 lines only. It is very simple. It will be coming for 1-2 marks in your board examinations. Okay, so this is the importance of formula which we have learned. Now we shall do, you can pause the video and you can take it down. Then we shall go to the next questions. That question is asked in 2013 in your CBSE examinations. Okay, so you can pause the video and take it down. Okay, fine. So aluminium crystallizes in a FCC. So question is aluminium crystallizes, crystallizes, crystallizes in a FCC structure, okay, aluminium crystallizes in a FCC structure. Atomic radius of the metal is, atomic radius of the metal is, okay, atomic radius of the metal is 125 picometer. Got it? Atomic radius of the metal is 125. Calculate the edge length of the unit cells of the metal. Calculate the edge length. They are telling us to find out the edge length of the metal. So what are the informations they have given? The informations they have given is radius, R equals to 125 picometer. Fine. So they have given R equals to 125 picometer. Another information they have given is the structure is FCC. So for FCC structure, the relations between R and A is given below. Okay, so the relations between R and A, So what is the relations between R and A? We have already written. For FCC it is A by 2 root 2. This is what we got. So radius is given here, 125 equals to A by 2 root 2. So if you cross multiply it, then it will be cross multiplied. Then you will get A equals to 0, 5 and 2, 250 root 2. So 250 into 1414. So you have to multiply it. Okay. So when we multiply 1414, then you will be getting what? By 25 you multiply, so 20 to 7, 25 to 7. Then next we will be getting 8 to 8 2. So 0, 15, 3, 15, 3. So here decimal is 3 place, so it will be 35.350 picometer. Okay, so we got 35350 picometer. If you want to convert in others, then you can convert it, no problem. Okay, got it? If you want to convert in other unit, you can do that also. So this questions was asked in your All India CBSE 2013 CBSE. Okay, so that's what these questions becomes important. Okay, dear friends, so hope you have understood the concept behind it. Okay, so this question is done. Now we shall see some questions which is been asked in the competitive examinations based on these formulas. Okay, so in the competitive exams they have asked questions based on these formulas, so we will see that also. Okay, so the questions here asked is okay, let me rub it. Next we will discuss based on these topics. The questions asked is, if A is the length of the side of a cube. So question is, this question is asked in which year? AIMPT 2004. AIMPT. Okay, AIPMT. So 2008. Okay, this question was asked in not 2008, it is 2014. This question is asked. What is the questions? Let's see the question. The question is, if A is the length of the, if A is the length of the side of a cube, of the side of a cube, of the side of a cube. What is, if A is the length of the side of a cube, comma, the distance between the body centered atom, the distance between the body centered atoms, okay, and one corner of the atom in the cube, and one corner of the atom, and one corner of the atom in a cube is, okay, they have said, if A is the edge length of the side of a cube, the distance between the body centered atom, okay, the distance between body centered atom, BCC, and in BCC one is in the centered, right, whole part, and one corner of the atoms, the distance between the body centered atom and one corner of the atom in a cube is how much it will be. Okay, so how much distance it will be there, we will be seeing to it. Options they have given us, option number A, it is what, 2 by root 3a. B options they have given us 4 by root 3a. C options they have given us root 3 by 4a, and D options they have given us root 3 by 2a. Okay, so they are telling us, find out which option is correct one. Okay, Got it or not? So it is asked to us to find out which option is correct. Got it? So all of you can try it once. Okay. So here what will be the answer here? Once So dear students, how we will do these questions? See here, it's very simple. Bcc structure, we know that at the center there is one sphere, and this sphere is at the corner, and this another sphere is at the corner. Okay, so like this it is to be there this way. This is the cube. Okay, so they are telling that the distance between the body centered atom. So this is body centered atom and one corner of the atoms. So one corner of the atoms. So this is the one. Okay, so this is the one, we have got it. So this one is what? Here is R and this is R. So this one R plus R becomes what? Diameter, right or not? But we have the radius relations for BCC. We have already discussed for BCC. What was the radius relations? Radius relations was √3/4a. So they are telling us find out this distance. So this distance is what? Is equals to diameter or not? Right? It is equals to diameter. So diameter is equals to what? Diameter is equals to, you can say, twice of R. So here R is how much? 2 into R is √3/4a. 2 cancel, so we got √3/2a. So what is the answer? Distance we got what? √3/2a. So this will be your answer. So that's what I was telling to you all dear students, that questions from this chapter, it comes very easy. The only thing is that you have to learn the concepts properly. So for taking this you will get 4 marks. Okay, got it or not? Okay, so let's see, is there any more questions based on this? Okay, fine. They have said if you are done with these questions, let us do one more questions which was asked earlier. Okay, so questions in the NEET examinations and all, it's easy only. The thing is that you should understand the concepts properly. That is the main problem, our dear students. We are not doing it. What is the questions here? Here the question is question number, this question is asked in the year CMPT, CBSE MPT 2008. CBSE MPT 2008. This question was asked. So question is very lengthy. What is the question? If A stands for the edge length of a cube system. Okay. So question is, if A stands for the, okay, if A stands for the edge length of the system, okay, if A stands for the edge length of the system, simple cubic body, then it is given simple cubic body. Okay, the question is little lengthy, let me read out. If A stands for the edge length of a cubic system, simple cubic body centered cube and face centered cube, then the ratio of the radii of the sphere of the three systems will be what? So they are asking us which one will be the correct ratio of the radii of simple cube, body centered and face centered. So options is given here. Option number 1, 1/2 a is to root 3/4 a is to 1/√2 root a. Okay, this is option A. Another option is B. So 1/2a dot root 3a dot 1/√2a. Then C, it is given what? 1/2a dot root 3/2a dot root 2/2a. Okay, and then option number D, it is given 1a is to root 2a is to root 3a. So this is the options given. So now we have to remember what ratio they are telling. First they have said simple cube. First is simple cube. Okay. Second they are telling body centered. So body centered. Third they are telling FCC. So this one the ratio you have to find. So we have already got the formula. Edge length ka, what was simple cube ka? A/2 radius. Radius of body centered we got what? Body centered ka root 3/4a. We got it. Then FCC ka it was what? FCC ka it was A/2 root 2. So you select which option is the correct one. A/2 root 3/4a, A/2 root a. This is the correct option, so you will be taking it this one. Okay, got it, dear students? So this question was asked in 2008. That is why I am telling you that this topic, relations between A, D and R, it's very, very important for your examinations, not only for your board exam but also for your competitive examinations point of view. Okay, dear students. So since the videos length is becoming a little bigger, so we'll wind up for today's. Okay, so we have done the last topic we discussed is relations between a edge length, radius and diameters of a spheres in a unit cells. Okay, got it? And we have done competitive exams related, NEET related 2 questions which was asked in the previous year on this topic. We have done it. In the next class we will be discussing further like coordinations, number and all those stuffs we will be discussing, and then we will be discussing the numericals problem. Dear students, if this videos is helpful to you, please take 1 second time to subscribe the channel, because your single subscriptions, it will encourage us to record more videos and to help you out in this way. Thank you so much.